So in this video, I'm going to talk about some very simple applications of matrices to economics and business. Um, you have to remember that you are now introduced to matrices. You may have done a little work in high school, um, and much of it was applied to, I think, transformation and so. But you haven't really studied matrices to that extent where you can, deal with heavy applications. You know, as a matter of fact, there's a whole branch of mathematics that deals with matrices, and it's studied under something called linear algebra. Um, that's a whole, as I said, a whole branch of mathematics. And for you to really see the heavy applications, you know, for matrices to whether be it business or economics, um, you have to study matrices a lot more. You have to maybe do an entire course on it. And then you're in a position because now you have the rudimentary understanding of matrix algebra and so on. When you know that, well, then you can really deal with anything heavy. But just to let you know, and be aware that it can be applied to very, very simple things. I'm going to do some examples now in this video here where we're going to use matrices in simple, simple business problems, right? We're going to see business matrix addition, subtraction, multiplication, the inverse being applied, right? Um, and how matrices can be used to solve. Uh, well, if you have a set of conditions and you can model those conditions using linear equations, well, then matrices can be used to solve problems involving those systems. I think you had a little hint of it in high school when you solve simultaneous equations using matrices. So you'll see it, being broadened and widened and so here and used for heavy applications, right? It's quite interesting too. Let's start with simple maybe addition and subtraction, right? So this is a very simple one, right? Here you have the quarterly sales of, by the way, a lot of the examples come from an Indian writer, right? So if you see the money and so is expressed in terms of rupees, please don't be alarmed, right? Nobody in the Caribbean and so Diana is writing much about these things. So you have to borrow examples from afar, right? So yeah, so maybe these are the quarterly, sales of some company in 2 years, 2002, if I can annotate on slide here. Yeah, see the year 2002, year 2003. These are the quarters, right, for the 2 years. Jute. You all know what is jute? Anybody know what is jute? Let's take jute and make a bag, right? Where you put like a potato and so inside. Long ago, it used to come with rice and paddy and used to make hammocks and so with it. It would last many, many years. Jute is like a brown fiber. Um, and they make ropes out of it and so, right? Jute, a brown fiber substance they take from a plant somewhere. Mostly in Asia, right? India in particular. And all of you know cotton, right? And yarn too. These are all uh, they're natural fibers that they take and they make uh, cloth and ropes and so right. Yeah. All of that isn't necessary really. I know you might say, man, let's get out with mathematics, but it's good to know what you're talking about here, right? Good to know what you're talking about. Yes. So in the problem, they want to know total quarterly sales of jute, cotton, and yarn for 2 years, right? So you have 1 year separate, 2002 separate from 2003. And if I'm to ask you, well, what operation you're thinking about, and you hear total, right away, you hear the word total, right away, addition, right? That's what you must be thinking about. So we just add the two matrices, right? Unfortunately, the order of this matrix is what? 3 by 4. And same here, right? 3 by 4. Because you're the same order, remember that? You can now add them, right? The dimension, order, size, whatever terminology you want to use. The two are of the same order. You can now add them, right? You simply um, so here I'm doing the addition, right? Add the two, and remember how we do addition? Remember how we do addition? You just add corresponding elements. You add the 20 to the 10, right? You get 40, right? You add 25 to the 15. I'm trusting that the author correctly added 25 and 15 gives you 40, 22, 1, 20, it's 42, 20, and it's 20, right? Gives you 40, and you go on, you continue like that. This 10 and this 5, 15, this 20 and this 20, 40, and so on, right? And you add it all the row together. That's what you get, right? What was it? Jute, cotton, yarn, right? And this is for 2 years, 2002 plus 2003, right? First quarter, second quarter, third quarter, fourth quarter, right? And that's it. So you're seeing addition at work there, right? Addition at work. That's the one where we involve a simple subtraction. Simple subtraction. I want to spoil up my slides, so that's why I'm erasing everything. I want to use back these slides sometime. Let's take one. This one um, would involve subtraction, right? So we have some company, X Limited. They have the following sales of their products, A and B. Right? They're selling two things, and they're telling you here that it looks like uh, they have two centers, P and Q, maybe two outlets, where they're selling these particular products, right? A and B. I can give you an example with them names, and so it will only make the whole thing worthy, right? So two centers selling A and B, right? And they want to know, okay, of course, they give you the year totals, right? This Y, I think, is year totals for the whole year, right? And then they tell you, well, all right, the sales for the first 3 months is, or the first quarter, two subscript one is this, right? You want to find the sales for the last 9 months, right? So you got the first quarter. You want to know where, from then to the end of the year, what was the sale? What was the sale? That can be useful, um, for some reason. So what do you do? Well, you just do a simple subtraction of Q subscript 1 and using that. Not really forcing you to put a subscript 1 from the yearly figure, right? You have subtraction, and that's what you get, right? And you do a subtraction very similar to addition. You subtract corresponding elements, right? So 50 minus 30, you get 20. 45 minus 50, you get 30. 60 minus 20 gives 40, 70 minus 20 gives 50. Well, very simple. Shouldn't be difficult, right? You subtract corresponding items. This here is um, the sales for the last 9 months, right? Sales for the last 9 months. So those are two nice examples. You had one involving addition as the first one, and this one involves some subtraction. And we want to get a little more complicated now, right? You want to deal with multiplication, right? So let's see a problem that involves multiplication of matrices. So look at this here. All right, so a store, it seems to be selling a number of commodities, 4 different things I mentioned, C1, C2, C4, right? And they also have like 3 branches, B1, B2, B3, right? So they're selling 4 different things at 3 different branches. And well, they put all of them in a table there, right? And they're saying, well, what would if there was a 30% discount? Now it's coming on to year end and the things are taking up shelf space. One needs to get rid of those old stock, right? People want new things. People say every time I come to the store, one thing I see and I want to see something new. The reason why it's there to the end of the year is the thing is still selling. You're not in line with your customers. You're not in tune. You're not doing your market research. Those are terms you're not going to get used to, right? So yeah, you have to discount it. So it says, what did it say? A store discount 30%, right? 30% by the end of the year. So you want to know, well, what's the price? What's the price after the discount? What's the price after the discount? So you have to multiply all these numbers by what? Would you multiply by 30% or 70%? Which one? Think. 30 or 70%. Notice they want the value of the stock after the discount. They don't want to know the discount. They want to know the discounted value, right? Keep that in by the thinking. So it's not a tutorial, so I can't get your response. I have to give you the answer. You'll multiply the entire matrix by 0.7. It's like scalar multiplication, right? Scalar multiplication. So you just multiply the whole matrix by 0.7, and this is what you get. All right, so C1 will be sold for that, C2 will be sold for that, C3 will be sold for that, C4, and branch 1, branch 2, branch 3, you know? So that will tell you the price, the discounted price, each item or commodity at the various branches. Right? All these are tricks you should know. Notice price isn't the same at every branch. Don't think so. All these are tricks you will employ on us when you get older and you have your own business. You're managing somebody's business. So look, this area here, this thing is scarce. So even though one place might sell it, notice what? Let's say commodity 1 at branch 1. I like look at branch 2, 35,000. Both at branch 1 and 3. Notice the large sum they're selling it for 45,500, 49,000. Could be access to it is not easy. You know, you go in some of the interior locations, you buy a drink, so be $1,000, $2,000. Depends on where in the interior, you know. Yeah, all the tricks you almost pick up as you go along. All right, let's do something a little harder now. Stay on multiplication, you're not going too far. This is a very simple one. So 3 guys, let's just say they're business owners maybe, and they purchase biscuits of brands P, Q, and R. So one of them, Ram, purchased 10 packets of P, 7 packets of Q. Let me not read out all of these. right? All these details are going to be summarized. Notice again how matrices are powerful. But by the time you read this, it's so confusing. You don't know what to do with the information. But you can take a matrix and you could summarize this information so nicely. Of course, you do it on a table for us, right? And tables summarize things very nicely. But then to do calculations with it, you need a matrix, right? You need a matrix. Yeah, you can do hand calculation. You take each cell on the table and do calculations, but it cannot be or it wouldn't be as efficient and as a matrix, you know. And the amount of things you can do with a table is very limited. So when you formalize a matrix, you can do so much of it. Right? So I'm not going to read out all this information. All of this, well, I have it back here again, right? I have the information here, right? But here it is, all in a matrix. So these are the three guys. These are the products and the amounts they're buying inside here, right? This little thing is telling you the order of the matrix because the problem will involve um, matrix multiplication. So order is very important, right? When you multiply it. So they tell you that they spend, okay, they're buying brand fee for, you know, this is rupees, right? It's an Indian writer who gave us this example. So the cost of Q is 5 rupees, cost of R is 6 rupees, right? So yeah, and this is the matrix that represents cost. So they want to know, find the amount of money, how much money is spent on these three guys, Ram, Shah, right? So you take these two matrices and multiply them. Knowing which to put in front and which to put behind is very important, right? If you try multiply, okay, 3 by 1, you put this in front, and then you put this one behind, 3 by 3. These two numbers got to be the same, right? Before you multiply. So no, that can't work. But if you turn them around, you put it 3 by 3 in front, and then 3 by 1. Because these two numbers are the same, yes, you can multiply. And you're looking for a 3 by 1 at the end, right? 3 by 1. So let's see how we do that workout. Everything, man. Be more finishing the lesson. It's not this side, you know? So here's the multiplication, right? And remember how you do the multiplication, rows by columns, right? Rows by columns. So 10 by 4 plus 7 by 5 plus 3 by 6. And that's what you see here. And you take this row by this column, that's what you see. And then you take this row by this column, that's what you see. And you add all of them. Times. All right. Did I get it right? I think it should have been 93, huh? There's a mistake here. It should have been 93. But 93 is there. It's a typo, huh? 93 rupees, 160 rupees, 99 rupees. Right. So remember, anybody can make mistakes, right? Yeah. I'll fix that later. But let's do a harder one. This one is much harder now. And it would involve matrix multiplication. No? So let's see. Let's go. So here, a store selling 3 different types of things at 2 branches. Right? and you're given for a particular week the prices of the things, right? The selling price as well as the cost of it, whether you're buying the thing or, you know. So these are all the information you see in the here. That's all right? Good. So what they want to know? What's the store's profit for the week, right? Or this word using. They were asking for various methods of profit. Yeah. So find the store's profit, right? So you remember your well, you probably remember your basic consumer arithmetic. Profit is usually well okay. Um, how much you sell, your revenue minus your costs, right? I probably remember that profit equal, I think we used to say selling price minus cost price. So remember, this is various commodities that cost, different things at different branches, right? So it's a little more complicated than your, fourth form level of arithmetic, right? Good. So how do we solve this? Well, we have to first come up with revenue, all that was sold. So you have to multiply all the commodities, the amount of them, by their selling prices, right? That's your first step. So these are commodities, call the matrix Q. These are the prices of them. So we're going to multiply this matrix by this matrix, and we're going to get that, right? So we multiply these here by this here, you get 2,300, right? So just in case you didn't grasp multiplication, you get 200 by the 2 plus 350 by the 4, then the 100 by this, add all of that up, and you get that. Then you're going to multiply this by that, this, add, you got to add it, right? This by that plus 400 by this, and then 150 by this. When you add all of them up, you get that, right? So that's your revenue, right? So revenue is the quantity of stuff you sell and by the selling price, right? That's what this is. You multiply this by this. That's your revenue. That's all the money you're going to get, right? Branch 1 is going to gross 2,300. Well, we don't know when they say 2,300, if it's 2,300 times 1,000, right? We don't know. Because usually when you have these big quantities, you don't write it out. And similarly, branch B has made 2,850, right? So now that's not your profit yet. That's how much your revenue is. So you have to take out costs, right? And that's why we're seeing in the corner here, come back here, we have a cost matrix, right? So you have to multiply this now by the cost matrix to get the expenditure, right? You have to buy them things yourself in the store, unless you already manufacture yourself, right? And even the manufacturing process does take some inputs, right? And they have costs attached to them. Well, so this is the cost matrices now. The quantity by the cost matrix, and you get this, right? So you multiply this by that, plus this by this, plus this by this. Add them all up, you should get. Similarly, you multiply this by this by this by this. Add them all up and you get that, right? So that's your cost matrix. And here what is happening is you're putting it according to branches, right? You're putting it according to branches, right? How much the cost incurred by this branch and the cost incurred by that branch, right? And then of course you can subtract, right? I think for us to get our profit now, we have to do a subtraction. We have to subtract our costs from our revenues, right? That is what's happening here. Your profit for the fourth store or the fourth branch, right? It's that, and the profit is that. You want to know total profit, total. Then you just add it to number, right? 550. 550 plus 675, right? I don't know if this is times a thousand. That's all, right? Put it in dollars. This one involves a little more work, eh? And I notice it drew on your background knowledge. You have to know that, well, okay, well, if I'm selling this thing and, I need to find everything that you're selling in your store has a cost. You bought it for something, right? And then you have a selling price, which you put some kind of profit margin on, right? So you have to know all those things. Profit is not just for you collect at the counter, you check out counter. No, you have to take out costs from that, right? Keep that in mind. Good. So I think we did a lot with addition, we did subtraction, we did scalar multiplication. This one involved um, some other multiplication, a little more complicated, right? Um, yeah, we did all the basic arithmetic. It's time to get a little more complicated now. So here's an investment problem, right? Somebody is investing in bonds, right? Somebody selling bonds, some company wants to get some money to expand or what. This portion um, is actually doing some investment. All this information is very complicated, very complicated. By the time those law books, by the time you reach the end of the law, you want to know that the end contradict the beginning. How do you capture all of this in a sense? Okay, so let's look at a more difficult problem where we may have to find the inverse. Um, yeah, the inverse of the matrix and so on. So we'll do a 2 by 2 um, matrix way. Very simple, right? Maybe during the tutorial and so I'll probably have a problem that would involve a 3 by 3 matrix, which will be much more difficult. Right? But this one involves just a 2 by 2. Right? So it's an investor making an investment in 2 types of bonds, right? One paying 10%, the other one paying 15%. The expected return in the first year is 4,000. Notice this is again an Indian writer. So he's got more rupees, 4,000 rupees. And then in the second year, he's kind of upping his he's upping his investment. Yeah. He is increasing his investment by 20% on this type of bond, by 10% on this type of bond. And he's going to earn $500 or 500 rupees more, right? So we want to know what was the amount he invested the first year, and in the second year, how much did he invest? Right. So let's see if we can, some of these problems, by the time you reach the end, you want to know, well, what were we talking about? The beginning is kind of fuzzy for us. And that's where, algebra, matrices, and so can really help us. So let's okay. So here it is again, the problem, right? So let's take this first one. So initially you are okay, he invested X amount in the bond A, right? And he's going to get 10% interest. And then bond B at 15% interest, and all of that will add up to 4,000 rupees. So don't mistreat it, right? So you do some algebra, I leave you to see how you can move from there to there. Don't trouble me with that. You see how we move from there to there. Good. Now, what about the second year? Second year, it says he's investing 20% more in this bond, A type of investment, right? So what's that? So it's 20% more. So that will be what? 20% more is like 120% of what he invested before, right? Which is what? 1.2 of X, right? But remember, you're getting a 10% return on bond yield. So 10% times 1.2x, which is 0.1 by 1.2 will give you this here, right? Here. And similarly, I think he says he's investing 10% more in bond B, right? So again, 10% of it, so it's 10% of X, which is how do you do that? 1.1 of X, right? And then you're getting how much return? 15%. 15%, which is 0.15 times that, right? So 0.15 by 1.1x. So give you what? It should give you the 0.165. Let me just check fast. 0.15 multiplied by 1.1. Yeah, 0.165. Yeah. So you get this here, right? And remember, you get $500 more than this 4,000, right? So you get 4 or 5 as your return. And then, well, you see if you can figure out how is it that they move from year to year, right? You get rid of all the decimal points and cancel them and do some work for once in a while. So after we do that, now we formulate our matrices, right? So we take that, we write it in matrix format. Of course, you would solve this algebraically and get your answer, right? Okay, but using the matrices, you get AX equal to B, right? So this matrix is A, this is X, this is E. So your problem is to find the matrix X, right? Which is X, Y. That's what you want. So if you were to rearrange this formula, X then would be equal to A inverse B, right? That's what we got to do. We got to find A inverse. Let's do that. Let's clear up this over a second. So this is what I was saying before, right? To get X, you have to find A inverse times B, right? So to find the inverse, you have to find the determinant. So the determinant of this is going to be what? 2 times 11, which is 22. Subtract 8 by 3, which is 24. So minus 2. The determinant is minus 2. Right? So the inverse is going to be minus a half. Remember, it's 1 over the determinant times the adjoint matrix of this, which means to switch around the 11 to change the sign of the 3 and 3, right? That was happening. So instead of multiplying this into the bracket, don't do that. Multiply this by this, right? And you get some nice numbers, and then you multiply by the minus a half, and you get some nice flush numbers, you know? Those are all tricks you should pick up. And when you multiply into the bracket with the fraction, you end up with all a set of fractions, which makes things complicated. So don't do that multiplication, do that last. Because the rules allow for that. The rules allow for that. Right? And then that tells you then that X is this, Y is that. Right? So in the first year, you invested $10,000 on A bonds, $20,000 rupees, sorry, on B bonds, right? And well, the second year, well, you should figure this out, all right? The second year, right, this will be almost 120% of this. And I think this one is 110% of that, which is that, right? So those are basic arithmetic that you should be able to master, right? But I just, the important thing here is to see how the matrix could have solved the problem, right? You could do your algebra, no problem, right? But I advise you know this because you never know how I set the question. That you have to know the matrix method, right? I'll set it in such a way that you have to know the matrix method, right? Um, so, okay, so yeah, let's do one that involves now you have to make use of determinants and inverses and all that, right? I think this one here, you don't have to find the inverse because they're talking about using Kramer's rule. I didn't really cover this in the previous lecture, but I'll give you a quick rundown. As I just said, we're just doing an introduction to matrices. I can't teach you all the rules there. I can't get into, reducing a matrix to echelon form and reduced row echelon form, and I can't get into all of that. That's a course by itself. That's going to take us weeks upon weeks, right? What I'm going to do, I'm going to show you what Kramer's rule basically is, right? It's a quick way where you avoid finding the inverse, right? Which is a good thing. So we're going to avoid finding the inverse. You just needed a determinant, right? So look at this problem. So this company is producing 3 different products. The total production for a certain day is 45 tons. And this is some pieces of information they're telling you, right? Production of the third product exceeds production of the fourth product by 8 tons, while the total combined production of the fourth and third product is twice that of the second product. Determine the production level of each product, well, they asked by Kramer's rule, right? So this is a very complicated situation that we can express algebraically, right? And that's what we're going to do. So we'll do that. So it's the same information. So 3 production levels, right? X, Y, and Z, in all they're 45, right? You say the third product exceeds the force by 8 tons. So this is equals to force 1 plus 8, X being the force product, right? What else they told us there? Well, okay, they're just taking this one and rearranging it here, right, to get that. I think the next part of the information says the third product, no, the total combined production of the first and third product is twice that of the second product. That's what they're telling you. These two combined, the first and the third, must be equal to twice the second one. So we can take this, rearrange it, and we get this equation. So we have equation, this first one, we have this second one, and we have this third one. You know, take those now, put it in matrix form. Mind you, if you know your algebra very well, you could solve this without even knowing matrix, right? But we're going to do it using a matrix method. So you take the coefficients, 1, 1, 1, minus 1, 0, 1, 1 minus 2, 1, put all in a matrix there, times X, Y, and Z must add up to 45, 8, and 0. So you want to find X, Y, and Z. What's this Kramer's rule business they're talking about? Right? What's the Kramer's rule they're talking about to find X, Y, and Z? And it's very simple. It's good to know because it solves the thing very easily, right? Let me tell you what the Kramer rule is all about. Let me go to it. See it's on the diagram. So first you take this matrix and you find the determinant, right? See, they're taking it and finding the determinant. Get 6, right? And you might ask how, right? So you can, okay, take this first number here, 1. You can do the first row, right? And you cross out this and this row, and you take the determinant of these 4, right? This is this matrix that is left. So the determinant of that first matrix here is equals to 1 times 0 by 1 is 0 minus 1 by minus 2 is minus 2. Sorry, so that's going to be 0 minus minus 2. It should give you 2. Right? I hope I'm getting right. 0 by 1 here. Minus 2 will give you 2. Minus, come to this number here. I have to erase. So I come to this number here, right? I cross out column and the row associated with it. And here now, well, that's 1, right? The number is 1. Times the determinant of these 4 here, right? So minus 1 by 1 is minus 1. Minus 1 by 1, right? Which is 1. So minus 1 will give you minus 2, right? Plus, no, plus here. And now take this one in. So you get 1 times the determinant of this piece here now, which is minus 1 by minus 2 is 2. Minus, well, 0 by 1 is 0, right? So you get 2. So what do you get as your determinant? You should get 6. Let's see, are we getting 6? 2 plus 2 plus 2, that's 6, right? Here we got our 6. And you do the same thing now. Now notice what happens here, right? The determinant of the matrix that will actually give you the x coordinate, right, is when you take this 45, the 8 and 0, and you replace these elements here. Notice that 45, 8, 0. You do back the same process and you will get the determinant to be 6. The second determinant you want to replace the second column now with this matrix here. That's what you see here. And you find the determinant again. And then you do the third one now. You strike out this last row and column and put 45, 8, and 0. That's what you have here. Right? And you find the determinant and you get 1, 1, 4. And what Kramer's rule is saying is that x will be equal to what is that? Delta 1 over delta. Y will be equal to delta 2 over delta. And z will be equal to delta 3 over delta. Right? And that's what you'll see on the other page. You know what? Before I go away, let me at least do one more of the determinants before you want to know where man hurrying ahead and that. Okay, let's say we want to find the determinant. You gotta get 6 and 6, right? That's what the people have. So you take this first one first, right? 45. Okay, put the number 45 times. Cross out this column, cross out that row. And you have to find the determinant of these four. 0 by 1 is 0. Minus 1 by 2 is minus 2. So minus minus 2 becomes 2. Right? Next, put a minus sign. You start with a plus, you go to the minus, and then another plus here, right? Good. So let me go and get the other one. It's a lot of work, never easy. So we go with this one, right? Cross over this row and this column here. So you get 1 brackets. 8 by 1 is 8 minus 0 by 1 is 0, right? So 8 plus, all right? So I know. So you go with this one, right? You go to row, column. You get 1 times, you finally determine this. 8 times minus 2 is minus 16. Well, 0 by 0 will be 0, right? So minus 16. Let's see. This will be 90 minus 8 minus 16. And well, I want to guess that that's 66 indeed, right? And you do the same for this one and that one, right? Good. And let's see what Kramer rule turns out now as our answer. As I told you, Kramer rule, write it back one more time. X is equals to delta 1 over delta. Y will be equal to delta 2 over delta. Z will be delta 3 over delta. Right? That's Kramer's rule. And that's what we have, right? So, and that's our answer. The production levels are first product 11 ton they made, second product 15, third product 19 tons. Right? So don't be scared of Kramer's rule. It's nothing hard really. It saves us if we have to go find the inverse of this function. Of this. Let me go back. If we have to find the inverse of this here in order to get x, y, and z, right? Because x, y, z will be equal to the inverse of this whole thing here, the inverse times 45 to 0. And this is a lot of work, right? Kramer's rule makes you avoid finding the inverse. See, so if you can avoid it, all well and good. Just to save yourself some time. Okay, let's move on. And this is our final set of applications, right? Um, Good. So now let's, these are some further applications of matrices to, problems in economics in particular. Less business and more economics, right? And these models, I think the man's full name is, not his full name, his first name is Vasily. His last name is Leontief. The Russian economist, I think. Right? As a matter of fact, this man won Vasily Leontief or something like that. He actually won a Nobel Prize for economics in 1973, right? That's the year I was born. Yeah, he came up with these ideas where you can actually analyze the economy in terms of, how the various sectors contribute to it, how much they use from it, and how much you can eventually have to, well, for export purposes, you need a lot of high-tech work, right? And I'm gonna tell you what, it's not simple, right? So we have to water it down for you to understand it. So what I'll do I'll do the open model, because the closed model involve matrices where to really solve the problem, you have to do something called you have to reduce the matrix, and there's something called echelon form, and then there's one called the reduced row echelon, So I haven't done that with you. That would have taken another week of work more, and it's sucking up valuable time in the course. It's really, a lot of work. So I'm gonna skip the closed model and do an example with the open one, right? I'll do this one. So here it is. What's happening? Yeah. Yeah. So this is a situation with the open model. And basically what the open model is about is, okay, various sectors of the economy, they're going to produce things, but they're also using. And then their surplus is what is used for, let's say, other consumers, right? Whether be it the export market or, outside of their sector, right within the country, right? So notice the information given, right? That, all right, in this particular economy, the farmer is producing whatever the farmer produces, sorry, we don't know that. 20% he uses, 15% the carpenter uses, 10% the tailor uses. And there's a surplus. And they say that, the consumer uses that. And they put it in dollars, $40 billion worth of food. And similarly, they go on to say, well, what about the carpenter? The carpenter, whatever he is using, 10% or whatever he's producing, sorry, 10% he uses. 25% is used by the farmer, 5% is used by the tailor. And $50 billion worth of what he produces, where it's available to the consumer, right? It's other sectors then. And then it goes on to talk about the tailor now, right? 15% of the clothing is used by the tailor himself, of all that he produces, 10% by the farmer, 5% by the carpenter, and he has a surplus of $60 billion that the consumer is free to use, right? And that is really, they can export that surplus, right? So here we have all of it kind of captured in this table here, right? And they call it a demand matrix, right? This is what is available for export purposes, right? So yeah, the 40 to 50, $60 billion, and that each sector is kind of producing surplus, right, for the consumer. Cool. So we're going to take this table and all these numbers here, and we're going to make up a matrix with it. And they're capturing it here, right? That's okay. So this is the whole set of matrices, right? So whatever the farmer, the carpenter, and the tailor is producing, right? We don't know how much, we have to find that out, right? And remember, we talk about how much they're using as well as how much other people are using from them, right? Let me multiply all these numbers by the X, Y, and Z plus what they have surplus, the demand, right? That they can actually export to other sectors. All of these add up to the X, Y, and Z, right? So this is the matrix, and this is in the form of X being this matrix, A being this matrix, X being this matrix again, D being this matrix, right? So let me take this matrix and this matrix equation, as they say here. take this matrix equation, right? Because that is this. Taking that, and we're going to do a little bit of rearrangement. Do a little bit of rearrangement, right? And this is what we did, right? So we had the matrix equation, this. So we bring this over here, right? And when you factorize out x, you're not getting 1, right? You're getting the identity matrix, which is, I don't know if you remember the identity matrix when I was telling you about that. 0, 0, 0, 0. That's the identity matrix, right? And for addition, that is, and subtraction, right? If you were to add anything to this or subtract anything from this, well, that's a matrix. That's the identity matrix. So in this case, you are subtracting something from it. If you subtract this matrix from another matrix, it remains the same. But in this case, you are subtracting A from I, right? So you will have a difference. So we take the matrix A, which was given before, subtract it from here, and you're going to get these numbers. I minus A is this. Now we want the inverse of it. Of course, we're not going to do the steps in finding the inverse of this. Why I tell you that is that there's software that will give us this inverse at an instant, right? So I'm not going to do all these decimals here to show you how to get the inverse, right? Software has to take care of that one, right? Keep that in mind. If you were to follow the procedure we did during the last tutorial and so on, yes, you will get it, but it will take quite a bit of time. So by now, you have to have a software that does it for you, right? Well, and we said up here that x is equals to the inverse we found times d. And that's what we do. We inverse by d gives you this. What's this really telling you? Well, this is the value of x, that's the value of y, and that's the value of z. In other words, these are the amounts in billions of dollars that, well, who was it? The farmer is X, how much they will have to produce. The carpenter is Y, and the tailor is Z, right? So in other words, the farmer has to produce 83.79999 billion dollars worth of produce. Same thing with the carpenter. He has to produce $74.2341 billion of whatever he produces, right? Construction really has to do to that work. And the tailor, in terms of clothing, he has to produce 84.813 billion. Only then will they be able to satisfy this economy, the demand, where what they're using, right, and what they have surplus to export, right? They have to be producing at this level to satisfy that demand, right? I think that's what they're telling you here. All right, so remember these are billions of dollars, right? It's not $83.7999. It's really 83.79999 billion, right? Keep that in mind. So this one is a little more, difficult and so on. But that's the closed model. This is the open model that this Wassily Leontief guy came up with. Mind you, this can get very, very complex. Right? This is a very, very simple one that was given to you. Right? Yeah, so that's a little bit of, some applications of matrices to problems in business and economics, right? As I said, we have just begun to wet our feet with matrices. If we have to maybe do a whole course more in matrices before we can be able to, really do the heavy stuff, right? And then we can get into more applications and so on. Right? But this is sufficient for an introduction, right?